All right. Welcome back, everybody. This is the Virtual Residency Workshop 2023. This is our 9th annual workshop. It's Tuesday, June 27th. And it's the first talk of the day. And I want to welcome our first speaker, Greta Kellogg from Penn State. And Greta, take it away.
Good morning, everybody. I see Sean is grabbing coffee. It's a quiet group when they get on. Not so used to that. It's really great to be here. Let me just go ahead and share my screen. Thank you, Henry. I'm going to do that. And then I'm going to do this. And then I'm going to open up a chat thing just in case. And then Cassie had a question about captions and transcripts, which I do not know the answer to that question. So I'll go ahead and get started. Can everybody hear me?
Yep.
Yes.
Hear and see. Thank you. Okay, great. I'm the assistant director for a new center at Penn State, Center for Artificial Intelligence and Machine Learning to Industry. And it is a great pleasure and an honor for me to be presenting to this community, because whenever I attend any of these ongoing open events, as Henry calls them, I always feel welcome. And I feel like I'm in the company of fellow-minded research computing enthusiasts. So I will go ahead and talk on the materials that are described in the title. And I will do as some of the speakers did yesterday, share a little bit of my own professional journey because of the two goals that Henry set for us for this week for the workshop. So when he was asking, posing the question about what we are here to accomplish this week, we're here to learn how to work with researchers who are using cyber infrastructure. And we are here to learn about the profession of cyber infrastructure facilitation and CI leadership. And so what I heard and what I saw is that we are not supposed to be bogged down with a lot of technical content that you can get, and I'm sure you are getting from other sources. So those lists, though, I started already. If you want to open up the Google Doc for this talk at 9 o'clock, I'm looking over my shoulder. You guys don't see that, but you see it on your own screens, presumably. Follow that link for the Google document, and I started putting resources there. And what I thought would be really great, because this is such a great community, and because I know that there are a lot of people here that know what they do better than I know what they do. There are campus champions for many years, longer than I've been around in this space and in this community. And so I would appreciate it, and I think everybody else would too, if we continue to add to the resources as we go along. I'll stop too sometimes to specifically ask questions. So for my own research computing story, I ended up in research computing through meandering through enterprise IT and computer mediated communication. So like many people in the community and the CI professionals, my own journey as a research computing professional has been unique. I first learned about this community in 2019 in the before times as an ACI ref at Penn State. But I came up through a uniquely tailored graduate program in computer mediated communication. And I submitted my thesis idea as a proposal, and it was funded by an IBM CERT grant. And then I moved into teaching and learning with technology, as my master's had been to develop the first online course platform at Penn State for the College of Liberal Arts for Communications. And then I worked onto enterprise IT, supporting Linux and Active Directory services for the 170,000 user base that is Penn State. And I really enjoyed the constant change and the need to stay abreast of all the technologies. So I transitioned into IT project management for enterprise computing. And then I moved over to the dark side, into research computing, where you still have to keep up with all the changes, but I also got to learn and support some really incredible science and discovery work. So I enjoyed it very much. I worked as a research programmer, and then I dove even deeper to support research computing as an ACI ref, which is a term that isn't as common, I don't think right now. It stands for Advanced Cyberinfrastructure Research and Education Facilitation. Henry covered that yesterday in his talk, in his intro. I worked as an ACI ref and as a program manager in research computing for over a decade before I headed out to Cornell to lead a new epigenomics core facility. And then I was recruited back to Penn State to help found the new Center for AI to Industry. And so my talk today, like my professional journey, is going to be informed by the very experiences that I had in both enterprise and in research computing. So I just want to take a pause and do a gratuitous quick shout out to the campus champions and the research engineers that are part of the tremendous team of colleagues that I get to work with, and they support our faculty research and our research computing. So anything I share today that is good is because they have taught me well, and I will accept the fault and correct any mistakes that I may make along the way through the talk. And I would greatly appreciate, any conversations here on the chat. So if anyone would like to learn about the RISE team model at Penn State, please feel free to reach out to me directly outside of the talk today. They have also presented at PERC. I know a few of the presenters yesterday were talking about PERC coming up in July. And we do have materials that we can share out if there's interest among other schools. So 4 years ago, there were only 4 engineers. RISE stands for Research Innovations with Scientists and Engineers. And now there are going to be 13. There's 11, and there are 2 more starting this summer. So it's very exciting. They don't have their pictures taken yet. They haven't gotten on deck. So it's very exciting to see the work get supported. So when I took a look at the agenda for the week and the agenda for today, I realized that the talk that comes right after me is about how to conduct an intake interview. And that's foundational for what we do. So I thought what I would do is I would share from our intake templates and use those to help organize our discussion about systems, service providers, and technologies that you may want to think about and work with depending upon how your research interviews unfold. And hopefully the approach will be a help to provide various approaches and resources for your own professional journey. So I have already, Henry's already posted these on the materials in Google Docs. I shared the templates for intake for new faculty at the university, as well as faculty that are new to you or new to cyber infrastructure or new to research computing. So many of us that are giving the talks this week are naturally focusing our attention to the national resources that are funded and that provide services to all the researchers at various cost or at no cost to the faculty, because we don't know what specific resources are available at your own institution. However, I will share based upon experiences at Penn State and Cornell for me in my slides, and I'll trust that you'll be encouraged to reach out to other units at your own institution to find out what we accomplish by working together with enterprise IT, enterprise networking, licensing, the grants office, etc. Like, by all means, be scrappy, find resources and leverage them as you need to. It all works better when we all work together. So that also reflects my own meandering journey through various research computing support units. And I tend to think that a lot of the problems that the researchers face and they come to us with are not technically impossible, but it might take some people working together to make it available for them. So what I do, per our conversations yesterday, was I take this template when I was doing the ACI ref, and now we have an awesome ACI ref around who's part of our team, but send this out to the researcher ahead of time. And while they have it in front of them, like I'd send it out ahead of time, then I would also bring it And then while they had it in front of them, because none of us read what gets sent to us ahead of time, when they had it in front of them and that was like organizing our conversation or sharing it over Zoom, then I have the Excel spreadsheet that you see on the right-hand side, and I would just tick off different things in different units so that I can easily translate that into a rate sheet, because that's how we do things here. We create SLAs and we assign rates, and that really, this process of sharing it in advance and then sharing it again with them in person, and then collecting the information. And as you collect the information, you check off the services, and you know in your Excel spreadsheet, like what the rates are for the various services, then you can kind of quickly assess what it will cost when you are like planning for their move to the institution, the first 3 months, the first 6 months, the first year, 3 years, 5 years. So these templates are provided there in the Google folder, Google Drive folder. And just a quick conversation about what's included on this are some really standard, straightforward questions, like who is the researcher? Where are they coming from? What do they think they're bringing with them? Including what kind of equipment do they think that they are bringing? What kind of data do they think that they're bringing? How much data? Are they assuming that they can sneakernet it? Can they sneakernet it? Or are you going to set up Globus transfers? Are you going to work with the research computing facilitators or, you know, whoever is available at the other institution to make the transition as seamless as possible? Ideally, this happens even before the faculty, the researcher arrives at the institution, but that almost never happens because you never get a hold of them until after they're here, and then they're in the, you know, needing something immediately. But this is a great way to go for those rare times, maybe when you can work with the faculty ahead of time. What our institute does, which I think is wonderful, is they work directly with the department heads. As they bring in new faculty, they will work with the departments and the deans to introduce the faculty to what's available with research computing. So taking a different perspective, and I feel like it will be more helpful to each of you to have like more than one model to look at. It can also help to organize the resources according to the categories that most of the faculty researchers find that they're going to need. And they're going to come to you to get more information and to help get started on their own or to have the services provided for them. So this is the example from working with the research computing group and the campus champions at Cornell. So these are the main categories of services that Cornell has organized for faculty for their research. Now, it is not by any means an all-inclusive list of all the research computing resources that are available at, you know, Cornell University or at any institution, but these are sort of foundational cyber infrastructure services that you know you're going to want to cover when you sit down and discuss the researcher needs. So Cornell provides HPC, data center, server maintenance. Everything that they provide, they call their red cloud. So the compute available is called cloud computing, and therefore any containers or any middleware or any sort of software applications are called cloud applications. They provide different tiers of data storage. And one thing that I truly appreciate is they support researcher websites and databases. Those really tend to be very high on researcher lists of things that they want to be able to do. And we'll talk about science gateways and other options later on. And also Cornell University provides programming and training resources. Maybe if your institution does not provide the outreach, Cornell would provide it previously for Exceed. They do still provide virtual, the Linux Institute and other education and outreach. If you don't have it on your own institution, you can always leverage what's available, and we'll go over options for what's available from different institutions. So I was trying to wrap my head around each of the categories so that I could figure out how to order the examples. And there are so many examples of each of the categories above that I just simply started dumping ideas into that Google Doc. Instead of trying to touch on every single option, what I have is I have a lot of links on these slides. So everything that's there is linked. And even as I was thinking to myself, like trying to think, what's the difference between these categories? I feel like the truth is many of the systems and many of the services are grid services or the consortia services. Many service providers, even if they are at one institution at a single location, they still provide large scale national resources. And there are so many technologies and tools that are built by the different consortia or by the different service providers. And they're applicable whether you're doing exascale computing or whether you're working with researchers on their local research computing facilities. So there's so many examples of each of the categories above that I broke it down like this. And I am relying on the fact that we have lots of links and we have lots of internet. And like I said, I decided that what I would do is I would talk from my own experience working with the systems. So I'd like to go over in terms of systems, access, DOE cloud computing. Access is funded by NSF, and I'm not as worried about the commercial cloud computing or the commodity computing. So I also don't have a lot of examples for the NIH resources such as BioWolf. That's a supercomputer at NIH that provides the researchers with an HPC cluster, high performance computing environment for biomedical sciences. So BioWolf is designed for large number of simultaneous jobs, which is really common in bioscience, and it supports large scale distributed memory tasks. The Helix Web is a web-based system, and it includes a number of web-based applications for analyzing next generation sequencing. Cloud Lab is an example of something that's a little more unique because they have a model that provides you with bare metal access as opposed to requiring containers or requiring VMs. And so they allow you to build your own software stack. You can do OpenStack, you can do Hadoop, you can do anything that you want from the ground up. But I decided I didn't want to work with cloud computing as much because I wanted to focus on, well, first of all, well, if we get to the end and we still have time, there is one that I want to cover, and I think that'll be fun. But in the meantime, I wanted to focus on democratizing computation and the Missing Million report that came out in 2021 from NSF. And a lot of the national grid computing and the DOE computing is available to the researchers and especially to small and medium institutions for free. And so that's a great way to leverage. And just to be clear, a lot of these platforms and services, a lot of these national enterprise scale systems actually will leverage AWS in the back end or Oracle Cloud in the back end or Azure, but they don't pass that cost along to the faculty researcher or to the institution because they're federally funded. So while they are federally funded, free to me is better than cost. But some of them are looking at doing different models. So we'll hit that as well. So starting with access. Access is, yeah, Jeannie's going away. Yeah, we'll talk about how some of these models, and I'm not sure if how many people on this call have had the same experience, but I've absolutely had faculty say, even if it's free, I don't want it. I would rather pay for AWS than have free because government pulls the funding after 5 years and their grants aren't done. You know, their grants get renewed. They still have research. They still have, work that they want to do. They don't want to move it. So I see both sides of that conversation. It gets a little complicated pretty quickly. So Access is an advanced computing and data resource supported by the NSF. It has supercomputing, visualization, storage systems. It's the lead institutions are Carnegie Mellon, Boulder, UIUC, and Buffalo. And I saw Boulder's talk yesterday, so feel free to shout out anything. But Access replaces the old Exceed. And for those of us who are working on Exceed, well, for me, I will speak for me. The thing that I found to be most different was that there were credits now. The whole threshold and tiers made sense because that was very similar to how it was before. Previously with Exceed, you would want to start with a startup application, and you can even work with your campus champion to get started with a startup application. It's actually not very difficult to go online and do an Explore Access and check out some of the systems that are available to you. And so the reason for those levels of access credits, as you're probably familiar, is to work with the researchers and figure out which of the resource specific allocations you will need after your project gets created. So credits are issued in 2 increments from Access. They issue half of them initially and half following your submission of a required progress report, which I don't think is bad. So my personal experience was that it seemed like a lot of researchers would either way overestimate what they actually needed and when they needed it and how quickly they needed it. Like they would be way over optimistic about being able to run millions of jobs when the code hadn't finished being written yet. And they have grad students that are working at a pace, and it's actually 3 to 6 months before any jobs are run, much less millions. So I think this approach actually makes sense when you start working with it. I would highly recommend that as you get started, that you first take a look before you create a project or submit for credits, that you first look at that credit threshold exchange calculator and use that to estimate, with the researcher, with sitting down with what they want to do and how much they need with the projects over time, keeping in mind that you'll get half initially and then half, after you do your progress report. So think about that. And keeping in mind that these are shared resources and all of us want to be good stewards, good neighbors. So I found that the transition from direct estimates of like CPU hours or GPU hours or storage requirements into credits was a little clunky and weird at first. But then, like any currency, you get used to it. And then I was able to appreciate how the value of the credits was more or less connected with the value of the resource or the demand for it. So like GPUs might take 4 credits more than a low mem CPU, for example. So that all made sense. Is there, much lower barrier access versus Exceed? I agree. I think that the that initial Explore Access is really low. It is the option to explore, which I appreciate, because that was a barrier for a number of faculty to even consider working off of these grids. So the next set that I want to take a look at, Department of Energy, Advanced Scientific Computing Research. And I do not personally have the much experience working with these like I did on Access and Exceed. Their mission is to discover, develop, and deploy computational network capabilities. They actually have a lot of both that we all rely on, whether we know it or not, on the national grids, but for things that are important to the Department of Energy. And right there would be this showstopper for, somebody in like biological research or cybersecurity, because it wouldn't be immediately clear that these topics are among the topics that DOE considers to be important. Like, you read something like that and you do the proposal and you're filling out the form and you're writing your research and you think, oh, this is biology. I got to go to Access or I have to go to NIH's clusters. But depending upon what the research project is, it may be very important to them. So it's not that it has to be, let's just think about all the things that have energy, including us after our coffee. DOE is actually interested in a lot of different kinds of phenomena, scientific phenomena. So the primary objective of their facilities and the allocation policy is to support science mission critical projects and to provide substantial allocations to the open science community through a peer review process for a small number of high impact scientific research projects. So all of that tells you what has been my experience. I don't know if that's other people's experience, but there's a much higher bar for your projects to be passed and to be given high amount of resources through here than through Access. The Argonne Leadership Computing Facility, the Energy Science Network, the ESNet, NERSC, and OLCF are all the kinds of computing labs that are probably here on the call. So I won't say anything negative. I don't have anything negative to say. I'm kidding. But they are all the kinds of facilities that you see written up in the HP 500. So researchers can apply for allocation of computing time on DOE HPC platforms through a DOE Insight Leadership Computing Program. And this is where it would probably behoove you as a research facilitator to reach out and contact the Insight manager and get a better understanding of their requirements for the Insight program, because that kind of initial legwork will help clarify if your project is one that would be appropriate for their own labs and for what the labs are working on. Oh, that's good, Jacob. So they provide more support for developing probably the novel open source software, perhaps. So in terms of accessing these labs and these supercomputing sites, I consider this list to be more like service providers and technologies. So they have the ESNet testbed. By the way, ESNet is rocking awesome. It develops tools and resources for network monitoring, for performance, and for the utilization of DOE's collaborative science programs. So Perf Sonar may be one that you've heard of at least, or you are familiar with. The ESNet high-speed network is another one that is very important and useful when you're transferring large data sets. So OSG is another category of what I consider to be systems and service providers, both. So established in 2005, the OSG consortium really focuses on high throughput computing services. And so we have sent grad students there to their summer programs. They have training programs for the grad students over the summer, and teaching them, it's perfect for the biological sciences because a lot of the biological science workflows are what we call embarrassingly parallel. They are a lot of jobs, millions of jobs over millions of files, but they do not need to be done in parallel. You just want them to be done parallel so that you can see the results before you're dead. So the open science pool, and I feel like their educational materials works really well for high throughput computing. They have also an open science data federation for sharing the data files and the storage capacity. And they have an annual all hands meeting. So any US-based academic, government, or nonprofit, so your nonprofit institutions can operate a data origin in order to export data. So if you want to have data available. For example, you're working with nonprofits, gathering edge computing equipment, sensor data, and so forth. They can have an OSG operated access point. And they have their own different technologies for handling that, kind of what's happening under the hood. But back to the original charge of, we're not going to get too deep into the technical details. Each of these systems and platforms have different underlying technology that they use and leverage. And there are advantages and disadvantages to each, but I appreciate OSG for kind of calling out, like, what they want are the high throughput jobs. So, if you have thousands, millions of concurrent cores, but not big cores, just a little bit of RAM, and then you really want to work with precompiled binaries or containers, that's the ideal. So this is fantastic for a lot of bioinformatic pipelines. Their motto is submit locally and you run globally. And the way this works is the Open Science Grid actually leverages downtime, so to speak, from different facilities and organizations throughout the US. And I know they have a world map. I'm not familiar with different countries that they have involved. They also have a software stack that is nicely supported. So OSG is open to providers at all scales, and this actually does really work well for small colleges up to large national labs. They have a great user community, like I said, that we had great experiences with. You can send individual students there from small labs to work and learn, or you can have them learn remotely, as we all do. And they're open to different business models for sharing and allocating and purchasing, and even sharing from your organization, if that is something that is of interest to you. Is high throughput a relative term? High compared to what? So yeah, so high throughput computing versus high performance computing. So if you take a look at the table, and on the right-hand column, like, so say that you have 4 jobs, but they have to be run in parallel. You must have like 16 cores running. You have to have a mix of CPU and GPU cores running. At the same time, you have epochs that are coming back and communicating back among, back to each other. You have a long wall time. Some of the human genome projects that we were working with would have a wall time of 100 or more hours, even with hundreds of CPUs in use in parallel. And so if you need high mem, so HPC is way out on that right-hand column. HTCs are high throughput, being lots that are less demanding per each one. Thank you, Aldo. Yep, and thank you, Henry. This is a great group to talk with, because everybody knows so much. And there's so many people coming from different perspectives. So the National Research Platform is a different model from OSG. They are a partnership of more than 50 institutions, and they have a lead from UC San Diego, and they're also supported by NSF. They have a hypercluster for running containerized big data applications. So not thousands or millions of small files, but big data files. And they utilize Kubernetes containers. That's one of the flavors of containers. And so they have they have a unique approach to the concept of equipment aging out and how that affects your nodes. So when a node that's running jobs gets hung or drops dead, the Kubernetes containers will logically offline and reboot it. And if the system doesn't come back up, then they get flagged, and they can either fix it or they can recycle it. So they're reporting that some of their GPU nodes are 5 years old already, but they have this approach where they're able to kind of eke out all of the possible life from these systems. So Another thing that's very interesting about the National Research Platform is their mix of CPUs, GPUs, and FPGAs. They have two types of FPGA subsystems, FP64 and 32 Optimus. And so they have like a whole buffet assortment of different options that you can take advantage of for various simulations, for machine learning, for artificial intelligence, for any of those kinds of mixed modeling approaches where you could actually program your software to take advantage of the various hardware efficiencies that are available. So to get started with Nautilus, it's a different process than what we saw a minute ago with either OSG. OSG is very easy to get started. You go, you log in, you present your project, you wait to get approved, and it's great. Access, we already walked through. National Research Platform, you go to their URL, you click join, contact, and it immediately has you work in, they call it a Slack space. I call it a Discord space. It depends upon, I guess, how old your kids are, or how much gaming you do. And they drop you right in to Jupyter notebooks that work, that help you set up your environment for what you need and for the jobs that you need to run. It actually works pretty well. And they are correct. Their Slack Discord channel, I think it's called Matrix. Yeah, it's called Matrix. Is very active and very helpful. In terms of other service providers, Pittsburgh Supercomputing is one of many that are available through the access systems of service providers. Bridges 2 is one of the newest clusters. I think it is the newest cluster in Pittsburgh. And it's got scalable HPC, machine learning data. It provides for data intensive research. And I like to give them a shout out because they were so good for us to work with. We are here in the state. So between State College and PSC, we had dark fiber between us. We could take advantage of sending our jobs. It was just like running locally, and they were so good to work with, and setting up science gateways in our situation. But I'm sure they would be like that for anybody, for any of you. I just wanted to mention this example from Access because I lived in Pittsburgh when I was young. I used the systems, and then I also met the co-directors, Mike Levine and Ralph Roskis, a long time ago. And so it just kind of has this like special warm spot in my heart. But Bridges 2 is not unlike Frontera or any of the other systems that are on Access, that provide the service providers that are part of that Access, used to be Exceed consortia, in that it has a lot of software that is supported on their stack. They have support for containers and virtual machines and databases. They do support gateways, as I was mentioning, and Globus transfers works phenomenally well. But I guess what I need to say is that's not unique. My understanding is that is the norm, working with various providers across the Access systems. So, talking about containers and VMs, yay! Yeah, I love PSE. Like I said, all right. So, service providers, Jetstream 2. We've also worked with Jetstream 2, and they actually do what my experience is. They are meant for interactive research, for small scale processing on demand, or they provide excellent backend services for science gateways. So if you're sending jobs to another HPC or to an HTC resource, so for example, we have science gateways running on Jetstream that can send their GPU jobs over to Delta at NCSA or to OSG for high throughput. or if you want to use them for general infrastructure. So if you have middleware requirements, it works out pretty well. The system is set up to be supportive of small colleges and universities, but like I said, it can also be for like specific kinds of virtual machine jobs. So their core capabilities are interactive virtual machines, like I said, Globus transfers, virtual desktops, and digital object identifiers. I have not used that last service from them. However, the OpenStack command line interface is perfect, works great, works with single sign-on for any of our CI logins. So yeah, this works well. Another example of a service provider, like I mentioned, like we use this for virtual machines. If you are looking and working with a researcher that wants a science gateway, then SGCI is your go-to. So the questions that you can ask as a research facilitator to the faculty is, are you building websites that serve your discipline, or do you want to create a community? Like when the researcher says, oh, I want to make sure that my bird information is available to any, citizen scientist around the world. That sounds like a science gateway. So when your needs go beyond advice, then they provide in-depth consultation, and they also provide gateways as a service. When you need somebody that maybe you don't have a lot of resources at your own institution, but then you can confidently, make the introduction for your researcher to work with SGCI, and they will take care of making sure that they work with the researcher to set up the gateways. So science gateways, if you're not familiar with it, they simplify access to computing resources by hiding all of those complexities that we were sort of just barely touching on a minute ago. They have on their website a storybook, which is totally worth downloading or just looking at online. And they, through the gateway services that they have solid education and training. They do have a community and a network of people that are supportive, but their storybook is so great. So they have a lot of really excellent examples of the different science gateways that they host and they've built and they've worked on together with researchers. And I found it to be actually incredibly encouraging to pass this along as a resource to the faculty members, because sometimes they have this like glimmer of an idea that, true example, I think I want to share images, slices, 3D slices of zebrafish, but I'm not really sure what that would look like. How would I do that in a way that engages the world and the audience? And, these examples that they have in their storybook have a whole bunch of different vignettes and pictures of different client engagements and programs that are outstanding. So, and then you don't have to worry about let me just say this, not that it would happen to any of you, but maybe only our faculty come to us with crazy ideas and you're like, oh my God, we're never going to be able to do this in our lifetimes. But if they get ideas from this storybook, then they're doable. So I actually like that part of it too. And then, so talking, a gateway ambassador at the institution, yay. That's a good thing. I did not know that that was a thing. So thank you. Thank you for sharing that. That's good for all of us to know. So Cybers is an example of one like Genie that is, the funding seems to be drying up. It's not the kind of thing that you put front and center on your website, but it looks like they are transitioning to a paid model. And the reason of doing this is because I wanted to let this community become aware that often when NSF funds the different service providers or the systems, they'll fund it for 5 years, then they have to be renewed, and then they can fund for another 5 years. I actually think that Jetstream just got their third renewal. They're on their third version, but it's different than my understanding of DOE and the national labs under DOE. They essentially have budget line items for those national labs. I don't know that that is infinite money or anything, but it's just a different model than having to resubmit for a grant that's going to be either approved or not approved. So for Cyverse, apparently they've been told that they need to be self-sustaining after 10 years. And that's a non-trivial conversation, because at that moment, you cease to become something that is, excuse me, that is something that is of value for the researcher at free. And you have to start competing with the Amazons and the Google platforms and the Oracle cloud structures of the world. And you need to, and you can see that almost in their tiers and features, because the data storage limit in particular is pretty low. The compute units per year might be fine, depending on what you're working with, what you're working towards. That wouldn't work for projects that I'm familiar with, but that's okay. So, and then I'm bringing up the example of Internet 2. So Internet 2 is absolutely, to my mind, it's first and foremost a community. It is higher education research institutions, it's government entities, it's corporations and cultural organizations, and they provide cyber infrastructure, secure high-speed networking, cloud solutions, research support, and services that are tailored for research and education. And then through In Common, a lot of the institutions, whether you realize it or not, EduRoam and single sign-on solutions are leveraging software and platforms that have been built and developed and supported through Internet 2. So instead of going through some of the items that I believe people are probably familiar with, or maybe you realize that your cell phone connected to EduRoam and you just didn't even realize why that happened, but you can thank them for that happening. So instead of focusing on the things that I think people might be more familiar with, I just wanted to bring to your attention some of the other sorts of initiatives that Internet 2 is working with. They have recently been funded 15 million from NSF for a minority serving cyber infrastructure consortia. And remember from the beginning, like the whole missing millions, that issue of democratizing access to computing is near and dear to my heart. So they got the funding to support acceleration of cyber infrastructure centric research at HBCUs and TCU campuses, any minority serving campuses actually. And so they are envisioning a transformational partnership where these advanced cyber infrastructure capabilities are now going to be available to historically Black colleges, to Hispanic serving institutions, to tribal colleges and universities, and other minority serving institutions. So they're doing that through community and capacity building, workforce development, research support and acceleration. And there are links in the materials for some of their work. I will just say this, signing up for their newsletter is excellent because they are new, energetic, energized, and they pass along, maybe your own faculty members have realized this, but NSF and NIH have pretty much said, don't submit proposals that do not have broader impacts. And every chance you get, make sure that you are partnering with minority serving institutions. Well, you can join this newsletter and you can see which minority serving institutions are actually looking for partners, as opposed to kind of inviting yourself over to somebody's place and they don't even know who you are. So this is a little bit nicer way to get involved in the community and have broader impact. So Internet 2 by the numbers, lots of numbers, big numbers, but like I said, they are a community and they have been providing high-speed network, cloud, research supporting education and services for research and higher ed. And they are another institution that also supports nonprofits. And I'm not sure, no, I don't, I think they, yeah, I think that they actually allow corporations as well. So not every one of these nonprofits will allow or will support, like, for example, SBIRs, STTRs, small, medium business. As soon as it's for profit, some of these are by design of their grant proposals not allowed to be involved. Internet 2, I believe, can support small, medium business, which is great if you're also supporting various entrepreneurial new applications. So now we're down to the technologies. And this is where I wanted to take a pause and give everybody a minute to put into chat your own favorite tool. Because there are, in my opinion, more tools than there are time to cover them all. Globus and Galaxy are near to my heart. I love Grafana. It's beautiful and amazing. I have mixed feelings about Hub. Nobody come and attack me. I apologize, but that's just where I am on that. Open on Demand, I think, is a fantastic platform from Ohio State to make strides towards democratizing access to high performance computing. I think providing that browser window interface that people are used to does that much more to separate your disciplines like art or English or even biomedical engineering, where they're not familiar with high performance computing. They might be taught programming, but they're not so familiar with HPC, and something like Open on Demand really makes that possible. So, Jeff is like, I want to learn about them all. Yes, they're all linked. They all have little videos, I promise you. Like, you can go, Jupyter Hub is king, that's fun. You can go and see tiny little videos, and actually that's one of the interesting things that I subscribe on YouTube channels for access, for CARC, for different things where they have these little videos that teach all of those little tools. One of them that I will call out is Ask CI. That was one of the first technologies that people pointed me to as ACI ref. And the difference between this and, Stack Exchange or something like that is that here you can get into a conversation with other researchers or with other ACI refs and find out, like, what is the best approach and why. Because some of these behind the scenes systems can start to get complicated quickly. And it's really great to have a community of people that can help you troubleshoot. Particularly if you're at a resource, you're in an institution that doesn't have a lot of resources for that. And in terms of, so the way I figured I would approach this is, instead of going through every single option, sorry, Jeff, but instead I would show you where to find the answers, because there are more tools to ask questions about and not enough time to cover everything. So Ask CI is one place. There's also a new knowledge base that is being actively developed now as we speak. So the Access Knowledge Universe, you can add to it. You can help to make it better. And Campus Champions, shout out to them, provide CI links. And these are also tons of crowdsourced links for training modules, for tutorials, but they also actually answer questions. So there are different tags about different kinds of bugs and errors and ways to fix them. So the Access community is meant to, they're trying to create these forums, and I think I have a picture of it coming up. So let me just talk about Campus Champions, and then I'll come back to that. So Campus Champions, by the numbers, the mission of Campus Champions is to have that diverse community of research computing data professionals that are sharing the knowledge and experience. So it's actually a different group. It's directors, it's sysadmins, it's user support, it's the trainers, it's coordinators, ACI refs, and there are a lot of people from the different communities like Access, like Internet 2, like Globus, like NCSA, that are around and lurking and being active members of these communities. So that's also very helpful. And I thought that if I have time that I could play this video. It's like a 1 minute and 8-second video, but I think I'm just going to keep going and let you take a look at this and open it. I thought it might be funny because so Dana's here and Dana's on the call and she's on the video, and maybe Susan and maybe others that I know are like here on the video and on the call, which I thought, oh, Henry, you say I do have time to play it. Okay. So let's see if I can do this. So go here, and can you hear it?
Yes, we can.
10 short years, we've grown to over 400 champions at over 200 institutions, helping to foster research.
Like understanding how flood risk will change with tropical storm patterns.
Developing optimized workflows for performance computing.
All while improving research computing networks nationwide.
And that's just small feat. Thanks to funding from Exceed
And the National Science Foundation,
Campus Champions have worked together
helping researchers, educators, and scholars to make the most of a variety of advanced digital resources to further research.
Folks from our goals as internationals to help solve problems by sharing and acquiring in-depth technical and user support skills.
By working together alongside 16 staff experts,
Here's to another 10 years of Campus Champions.
helping to accelerate research and innovation.
Yeah, so this is where it's intimidating because, like I said, there's a lot of really great campus champions here on the call. So I'm not going to take their watch and tell them what time it is. I will just give a shout out for this. And yay, membership is 832. Wow. Yeah. So if you're going to PERC, you will absolutely learn more, hear more, meet many of the campus champions. One of the things that I would bring to your attention is the campus champion programs, especially for if you're looking to have broader impacts at your institution, or if you are looking for ways to develop workforce pipelines and grow your students and your talent across disciplines. The campus champion program includes specialized champions, which includes student champions, which is a student perspective on the use of digital resources and services for research computing, and champion fellows, which partner with the campus champions on the extended collaborative support services, ECSS staff and research teams, and they get to work side by side with the science and engineering projects. So both of those are excellent programs too. Oops, there we go. So in terms of what you might be interested in, going back to the beginning of the talk, when we were talking about access, the campus champions used to support Exceed in a different way. Now they, in access, they're called affinity groups. And campus champions are among the affinity groups that work with people to help support access resources and the resource allocation system. So there are affinity groups and user communities that are in specific channels. There are Q&A forums, and there are events. We already took a look at the knowledge base. We already took at the CI links. And so this is an opportunity where each of you can also join Access as a resource provider in any of these affinity groups and learn and participate and become part of that community. you'll get added to the distribution list, and then you get notifications about outages, but you also get the notification about news and the training events that are upcoming, that are going to be relevant for what you are doing and working on with your researchers. So I just wanted to say thank you very much for your attention. And instead of asking for questions per se, because I have a few more slides if we do have time, which we kind of do. But I want, if you didn't get a chance, I want you to go ahead and put your favorite go-to resource in the chat. Actually, I should ask. Yay, I can save the chat. So Henry, do you save the chats and make them available so that people can work with them later? Make them available? No. Okay. So then what needs to happen is, that's why the Google Doc has been created and has been shared. And yes, that's great. I'm not questioning you. I'm assuming that's okay. But I will share here the link to the Google Doc for this morning's talk. Please add all and every one of those resources I didn't mention that you know are near and dear to your heart. So having said that, are there any questions?
Yeah, Greta, thank you so much. This was a great resource that you put together just in an hour. So that's pretty awesome. My question, that one of my pains is not the resources, it's having them outlined, because I'm putting up a new shop. I'll turn my video on too, so you see how someone I talk to. It's not someone having the resources, it's understanding what phase the resources should be used at. So deploying a new cluster versus trying to figure out how to optimize your cluster, or helping a researcher with a particular project and understanding and navigating that field. So there's so many of them, but there's no clear outline of like, this is you use these during this phase of your deployment or this phase of your deployment. Is there any resource that you've seen or that you're willing to collaborate with to make that more approachable, so that like you said, the insane amount of resources available to us are coherent and approachable?
Right. So in other words, like if you have a new faculty member, but they happen to be an astrophysicist that's looking for planets at the beginning of the start of the universe, and so they're gathering all kinds of petabytes of data from, you know, an observatory in Central America, that's a different starting place to start than, you know, somebody who has a small biochemistry lab and they have a few samples that they need to analyze off of a sequencer.
Exactly.
Yeah. I don't know of any. I don't know if anyone else does, but what I'm thinking in my brain is, you know, what we did it, I say we, because it was a number of us, probably back in the first center that I was part of, we put together a resource at Penn State for Penn Staters to kind of sort out like, okay, which clusters or which types of systems do you want to run your jobs on, for which reason? And so like expanding that to the universe of all things possible sounds very daunting, but like any task, I guess you could do it a bit at a time in the kind of open model that Henry talks about, like people just getting together and chipping away at it each and every week. So unless somebody knows that it's already done, speak up, because that sounds like that would be amazing. It just, the whole environment, the whole ecosystem of what's available, and people are always improving. what they have and what they do. I mean, that's kind of like, if you love this area, that's why you love it, because it's always changing.
Can I add something?
Yeah,
Yeah, so it's really difficult to go around putting out all the list, but what I did at my former institution, because we didn't have a lot of resources, so you know the needs of your users, and then you come up with, you just go around the national infrastructure, exceed national labs, and then look at those infrastructure that meets the specific needs of your users, and then just create a list and set it up as a service. I actually had it as a service. So if somebody needed something on access, some GPU or storage or at a national lab, yeah, I know how to start, where to go, and I can get them started. But if you want to do that for all the universities in the US, that can be really, really challenging.
right. It sounds like, yeah, you approached it kind of the way we did too. It's like, okay, we know that these are the needs. So that's how we decide which things we want to look at, as opposed to looking at all the things and trying to match them to whatever a researcher would come and bring. That's an important distinction to make, Jacob. Glad that you pointed that out, that if you start from the researchers that you know and the researchers that you're working with, that's probably the right way to approach that, to begin that conversation for the faculty that you support. I don't know, Kyle, if that helps you, but what Jacob just said helped me reframe it too. How do we effectively connect researchers and share the fact that these resources exist? How do we get them to read their emails? I've never been able to get a faculty member to read email. So like whatever tip you have for that, that's great. Oh, so this is the shameless, although I felt really good to hear Henry say that he also has these maniacal things. So my maniacal way of getting the message out is to go and talk with the researchers as much as possible in person, which is nearly impossible at a university the size of Penn State, but I try. Because when you do the small wins and make their lives just a little bit easier and a little bit better, and you I listen for what a small win, low cost, high yield, high reward can be. I do that. And then you've got their attention. Then you have their ear from, they'll print on you and you will have them for the rest of your life asking you questions. So be careful what you ask for. Yeah, right. You just got to keep sending the information out and not get tired of it. Yeah, those are really good ideas that are there in the chat. So, like I said, this is a great group to work with because everybody here knows so much more than me, so it's awesome. I have a quick thing because I have a few more minutes left. If there are no more questions, I want to share this with you guys. This is kind of like the extra, right? So what we didn't cover when we talked about cloud computing, and we didn't talk about the commodity cloud options. I think probably people on this call have heard of ChatGPT and probably have noticed that the students and the faculty might be pulling out their hair or they might be embracing it. The students are really curious about it. So Penn State Harrisburg just had, they were literally already planning a coding competition when ChatGPT 4 came out, and then they were like, oh my God, now what are we going to do? And so the faculty decided, Roderick Lee, Jeremy Blum, decided that instead of running away from it or trying to police it, that they were going to embrace it. And they just told everybody, you will be graded on your ability to properly leverage ChatGPT, anything, any generative AI. It's like bringing a calculator into your math exam. use anything you want, except do not ask another team. So within your team, go ahead and use any tool that's available out there. And they were hoping to get like 30 or 40 teams, and they ended up getting 130 students. And this is where, you know, you got to love the librarians, the library, you know, the labs there in the libraries were completely overrun. There were students packed up in the hallways. And each of these groups, there ended up being 52 teams. Some of the teams were like 3 or 4 kids. Some of them were, sorry for saying kids, some of them were, you know, 8 or 10. And where maybe only one student in that group knew how to do any kind of programming at all. The rest of them knew how to write questions in a chat box. And so they did. And what ended up happening was they had a lot of participants that came in, and oh, I didn't say anything more about it, but you know, the expectation in the future is that 20 to 30% of computer code is going to be written by generative AI. I bet it's already more than that now this month, just anecdotally by what I hear and what I see. So it's really important to get on top of this, but it also is really interesting because I was there for the event, how they ended up learning how to code. They weren't intimidated to come. They weren't intimidated to turn out. They were from all different disciplines. They were from all different parts of like different programs, and they came. Every single one of those teams, by the way, at least succeeded in one of the challenges. There were 100 challenges, and they got to be more and more difficult as time went on. Most of the teams got more than half of them correct without having a lot of programming depth. Like I said, usually there would just be one student on the team. So the reason why I'm putting this out and doing this call out is because it turns out that Microsoft Services is already putting in OpenAI services. And there's a comparison here in the slide for what comes with Azure. I believe a lot of institutions are drinking from the Microsoft well, for better or for ill. It is what it is. But if you have that licensing, then you have access to this. And the advantage to this, especially to me, is the security and data privacy if they promise to keep, because, and this is also a true story. I had a grad student that said he wanted some help with doing the abstract for his dissertation, and he put it in there and he said, "That's okay, isn't it? Just used it to help me." And I said, "That's okay, as long as you don't expect to keep your research private to yourself." So anyway, there's this option, and I thought that this might be something that the community might have access to. You might not be aware of it, or you might not be aware of its implication. So thank you so much for having me. Yeah, so worth the cost of subscription, but if the institution already has Microsoft services, like you have Office 365 completely forced upon you, you might as well leverage it and not have each of the faculty members pay the $20 or whatever the subscription service is, and just leverage it through the licensing that you already have available. So thank you very, very much for having me today.
And thank you so much, Greta. Let's give Greta a virtual round of applause. We are just a couple of minutes over our time. So we will be reconvening at 1:15. And at that time, Dirk Colbury and one of his colleagues will be doing the how to do an intake interview session, training session, including some demonstrations of intake interviews. So this is a very exciting session, and it'll be a really good lead-in to tomorrow's intake interview practicum, when we are actually going to do intake interviews with real researchers, and we have about a dozen actual researchers lined up for tomorrow. So we're looking forward to Dirk's session, and I'm about to download his slides and put them on the webpage, along with the link to the original Google Slides version of those as well. Dirk would rather me not do that. So Dirk can let me know. Anyway, so we'll look forward to seeing you in about 25 minutes. Thank you so much, Greta, and thank you, everyone. Stay on. Go get yourself, refresh your beverage, get a snack if you want, take a bio break, and we'll see you in 25 minutes at 1:45.